and welcome to the Lightstep session at the Application Architecture Summit. And I'm joined now by Stephanie Baum, Software Engineer at Lightstep. Stephanie, welcome.
Thanks, glad to be here.
You know, we're really glad to have Stephanie with us this morning. She currently works on the root cause analysis team at Lightstep. She brings a ton of expertise to that role. Before joining Lightstep, she was a full stack engineer at Stackery, and while at Accenture's Lightweight Architecture Group, she helped Fortune 5000 companies with microservice architecture migration projects. And that brings us to the topic of Stephanie's session, cracking the case, how to migrate from monoliths to microservices. You know, digital transformation often involves a project that requires microservices, and those that work on microservices know they can be finicky, but microservice migration often proves to be a real challenge. Stephanie will diagnose the issues that companies face when choosing the best tech stack, when splitting a monolith into services-based architecture. And she's also going to lay out some clear pros and cons to help you navigate those choices. And to help bring it all together in your brain, she's going to give us some terrific examples. So before I hand it to Stephanie, just a quick note, you could download her slides. I highly recommend you do. Just click that big red button under the view screen. And Stephanie and her team have also brought us some great white papers and other downloads. They're available for you. All this without any registration required, by the way. You did that to join us this morning. And we love to connect you with our speakers. So to ask Stephanie a question or make a comment, just type in the submit a question box. So with all that, Stephanie, let me hand it to you and tell us about cracking the case, how to migrate from monoliths to microservices.
Thanks so much. That was a great intro. Okay, so here is our session, cracking the case, how to migrate from monoliths to microservices. Just a quick intro before we get started. I'm Stephanie, a software engineer at Lightstep. Previously, I was a full stack engineer at Stackery. Before that, I was an engineer at Accenture in our lightweight architecture group. Essentially, I'm telling you this just to give you an introduction on my background. So I have worked with microservices and monoliths for most of my career. I've seen a lot of things to do as well as things not to do, and I'd like to share that with you today. So just a quick agenda here. I'm going to walk through a general service migration strategy with some examples in a little architecture diagram. And then from there, we're going to walk through how to de-risk a migration using observability and what modern observability for microservices looks like. And then lastly, we'll have a little portion of Q&A. So just to introduce our example here, this is a diagram of an example monolith. Basically, we have our API gateway on the left, and then we hit our monolith container with our API endpoints. This is a pretty contrived example, so bear with me. I tried to make it simple so that people can follow along. And then our API endpoints are calling out to our external system. So this could be external infrastructure, for example, like our MySQL database or something, or it could be third parties or other services such as SNS. In the case we're emailing a user, maybe we want to send emails out to that AWS SNS system. For example, maybe our login calls a third party like Auth0. So this is all in a container, but this is a monolithic container. And why do we call it monolithic? Well, all of these things are together and therefore they are not horizontally scalable. So for example, if I started getting a lot more traffic into one of these endpoints, such as the payment endpoint, I would have to make copies of my whole container instead of just making copies of that single functionality for payment in order to handle that load. So usually starting out, monoliths actually can increase velocity if you're trying to build something quickly, but eventually they break down at some point, usually if you are experiencing heavy traffic, for example, or basically just different traffic patterns that make monoliths no longer feasible, or organizationally, if you're starting to add more engineering teams, that also tends to be a reason for splitting up your monolith. So that's basically the intro of what we're looking at here in this example. And our to-do here is to split out payments into its own microservice and integrate it with a new third party. So that's this endpoint right here, this payments endpoint. And here's our goal state. So now we have got two containers. Payments is split out from the monolith, and we had no downtime, and we did not affect our end users. So we did not lose any revenue here. That is our goal. So again, we still have this monolith down here at the bottom, but we've split out this particular endpoint, payments, along with the external calls that are needed here to the new third party, for example. So as you can see, some of these external calls are repeated in both containers. In the monolith, we're still calling the authorization third party and cart storage, and we're also doing the same thing here in our new microservice, and that's okay. That just means we're using a shared library in order to call out to external systems, but our endpoints are now separated, and therefore the payment endpoint is horizontally scalable. So basically in this scenario, our payments are handled in the monolith. We want to, again, like I said, integrate with a third party, have that operating asynchronously from the rest of the stack. So I'm just going to go through here basically how I like to think of migrations and what I've learned, as well as some tips for planning your migration and doing that successfully, again, with no downtime. So the first tip that I have for this is to define must-haves up front and start thinking about SLOs up front that help to basically make sure that you're achieving those must-haves. So here's some example must-haves given our scenario. We want more scalability, more reliability. We want to successfully integrate with that third-party service. Let's say it's Stripe or something, for example. And we want zero downtime. And zero downtime means that we are not affecting any upstream services when we do the migration, and we are not affecting any end users. So first, let's talk about SLOs. Everyone seems to have opinions on SLOs, and no one really seems to know the best way to define them. I do have some general guidance, though, based on my experience. Also, just an aside, some people call SLOs SLIs or SLAs. Essentially, they're all the same thing, service level objectives that you basically use as indicators for the performance of your service. So first tip, define your internal service SLOs based on services upstream that rely on your service and services downstream that you rely on. So why do you do this? Well, firstly, services upstream that rely on your service, that's pretty self-explanatory. Essentially, you want to make sure that your service is fulfilling the contract of reliability to all the upstream services that depend on it. And this could also mean all the end user interactions that depend on your service. And then this bullet here, services downstream that you rely on. So when you're building out your new microservice, you may rely on other downstream services, including services that you don't control, such as your third-party authorization and your third-party payment service. So the reason that you want to set SLOs and monitor this interaction here is to protect your team essentially from blame. So when you have incidents within your systems or any kind of blip in performance, you want to make sure that you can clearly differentiate whether it's your team and your service's fault versus a downstream service that you depend on. If it's your third-party service, for example, you want to know that's what's actually causing the incident and it's not your own service. And you also want to be able to factor that into your total uptime score, right? So maybe your service's uptime is much higher than your downstream services uptime or something like that. Second tip here is to define executive level SLOs based on critical end user business operations. So think about your boss's boss's boss and what does he actually care about? Probably not these low level SLOs, but he definitely probably cares about, or she definitely probably cares about anything that's going to cause a loss in time, money, and users if it breaks. And this kind of goes back to our whole thing with zero uptime. So basically, we want to set these SLOs and directly map them to the value that we are providing with our microservice. And just an aside here, you can definitely use application performance monitoring tools that leverage tracing and metrics in order to monitor, measure, and define end-to-end SLOs. So the reason I mentioned tracing here is because you kind of need that level of context in order to actually both understand and define these, and that'll become more clear in this next slide. So here I've kind of diagrammed out how you would define your SLOs. So again, we've got this new payment microservice, and then we've got the end user. Maybe the end user clicks the pay button and it calls our microservice. Maybe it calls some other monolith or something before it. That doesn't matter. The key things here that are being affected by our service are this critical business operation and our own services SLO. So this could be like, for example, our response time or something like that. And then we've also got our downstream SLOs for our providers, whether that's infrastructure that we own or third parties, such as a third-party payment service. So just some examples here, just to provide some more concreteness. So an example provider SLA would be alert when the third-party payment service error rate is greater than 0.1%. An example internal SLA to my service would be alert when the pay endpoint, when it's P99 percentile, which is the 1% of requests are greater than 5 seconds. And an example critical business operation SLA, alert when clicking pay button on a validated payment options error rate is greater than 1%. So basically all of these separate SLOs kind of roll up to show us how our service is operating and how much it is affecting our end user value. So next I wanted to discuss operations. Essentially, you probably want to make a spike to figure these things out ahead of time if you do not have them set up already. So this includes things like configuration management, containerization, permissions management, and CI/CD. You want this all to be repeatable because you bet once you create your first microservice, you'll want to create more, and you probably want that capability to be easily repeatable and scalable across teams. Also, make sure to add any security must-haves and do any rough cost analysis upfront, because cost analysis will affect both how you architect your service and which external services you're going to rely on. It is not ideal to figure that out down the road, that you can no longer depend on some third party because you didn't realize it would cost so much for your scale. That's always something you want to do upfront. So a tip here also, this may seem obvious, but use a familiar programming language for the service unless there's a good reason not to. So I've actually seen throughout my career a lot of different approaches to this. Some companies like to just allow their engineering teams to do their own thing completely, to the point where they're using their own separate programming languages for separate services. And while in theory, this is probably making that particular team happy, what if someone leaves that team and then maybe eventually that team slowly gets replaced or starts working on something else? Well, someone's going to have to own that microservice eventually. And if they used an unfamiliar language, then that makes onboarding and ownership a lot harder. And here's a question that I get all the time. When should you use serverless or Lambda functions versus a traditional containerized microservice? So I would say this depends on how familiar your team is with the technology, specifically serverless technology, and how that works in your cloud provider, and then also how complex the business logic is. So going completely stateless to the point of serverless definitely can be complex when you have a lot of business logic that relies on state. And so in that case, sometimes I would recommend to not go straight to serverless, especially if your team is fairly new with serverless technology. And then another limitation here that people don't always think about, so if the business logic is going to take longer than 30 seconds to process certain requests, then you should probably consider using a short-lived container like Fargate, or just a traditional microservice. And that's because in most cloud providers, Lambda functions tend to time out at the 30-second mark. And that can actually be sometimes maybe 35 seconds or 40 seconds. The point is, if you need to plan to sometimes take that long, serverless is not the right choice. So next up here is the API contract. So how is the new service going to be exposed to the outside world? What kinds of requests does it need to handle to support any new functionality? So the easiest thing is to have the API contract not change at all. Usually that is not always the case though, especially when you're migrating a microservice out from the monolith. Sometimes you're also doing things such as creating new REST API endpoints where the monolith was previously using XML, for example. So define that contract up front, especially to unblock other teams that have to integrate with your new microservice. You want to be able to give them some contract up front so that they can actually start planning to call your new microservice as you're building it out. And my recommendation here is to use something like Swagger if you have time and want to enforce API stability. There are tools even that you can use that actually integrate Swagger within your code base so that your API definitions live right next to your code. And this can be very beneficial to make sure that stability is enforced and everyone knows what the state of the API is as you're building it out. I would also say definitely diagram and understand existing behavior that will be migrated out of the monolith, and understand current performance limitations within your monolith and add these to the must-haves list, possibly attaching SLOs to enforce any performance increases that you want to have in your new microservice, for example. And just an aside again about application monitoring. So you can use APMs that leverage tracing to understand current performance limitations and bottlenecks. So this is definitely, again, something where tracing comes in handy because it provides that contextual information both in your monolith and in your microservices in order to see actually where those code paths are going and where you will need to migrate certain behavior. It's kind of hard to do that. Otherwise, you'd have to trace through the code yourself or look at different logging and metrics to make sure certain pieces of the code are being hit or aren't, for example. Tracing really provides a lot of visibility, both in the existing monolith and in the migration process. So next point here is data flow. And this is really just thinking about data models in the traditional sense. In our example, what is the new logic and data model for the third-party service we are integrating with? So for example, if we're calling out to Stripe, what is the new third-party model look like? And how does that different from our existing model? And what kind of data transformations do we have to do here? And in general, what external infrastructure are we relying on in our new service? And how do we de-risk any external infrastructure that is new, for example, or that we don't know how to operate yet? So for example, if we're adding a new database type or something like that, we definitely want to have some kind of spike here to understand how we're going to own that new service and how we're going to de-risk any potential problems with that service. So tip number one here is to brainstorm risks upfront. So de-risking activity could fall under benchmarking, throughput analysis of current systems, management plans and playbooks, again, for any of that new external infrastructure or services that we need to learn how to run. And then second tip here is to create a plan for how to migrate the old service to the new one, and then plan for this plan to not work, essentially. So we want basically a game plan where we've figured out, okay, we're going to migrate this much traffic at this point in time, at this milestone. We're going to migrate this endpoint and then this endpoint, for example, or all of the endpoints together. When will we consider the migration to be confidently done? And assuming this plan totally fails, how will we roll the service back in various states? For example, if the new service has been running for 1 day and then totally breaks something, how are we going to roll back to the previous state? How will we even roll back to the old monolith if the new service turns out to not work for whatever reason? And that's really how to de-risk in order to have that zero downtime goal that we defined at the first place. So that was all the migration tips that I wanted to share with you all. Next, I really wanted to talk about exactly what the effect is of having microservices in your systems. So as we continue to do these kind of migrations where we're breaking out monoliths into more and more microservices, you kind of get this microservice effect is what I like to call it, where you basically maybe your team controls only one or a few services here, but as different teams continue to break out functionality, we get this multiplication factor in complexity where you may only control this service up here, but you're responsible for that SLO, and that may be affected by all these services down here that you are not even responsible for anymore that are downstream from you. So how do we understand where responsibility falls in this stack and what these services look like? Well, the answer is really it's more of an observability challenge. So again, microservices introduce complexity. We're going from something that's relatively straightforward to reason about into something that's decoupled and distributed. And it continues to get even more decoupled and more distributed as you continue to migrate into microservices. You also are introducing more points of failure by adding additional service-to-service boundaries and calls, and spreading out calls to infrastructure and external services. So what I mean by this, if you have a monolith and your monolith is the only thing that's talking to your MySQL database, well, it's pretty straightforward to monitor all the traffic that's going into your MySQL database and know where it's coming from. It's just coming from that monolith. If we add 10 more microservices here, and some of them are calling MySQL and some of them aren't for certain request types, how do we understand where the load is coming from on our MySQL database, and how do we basically understand what the bottlenecks are there and how that maps to our functionality and our different services? So next I'm going to show some shocking examples of real deep systems from our platform. So again, Lightstep is an observability tool that does integrate tracing. We do have this thing called service diagram, and it allows you to visualize your dependencies relying on that tracing data, where we do collect information about latency and error rate and things like that. And then we basically dynamically show that. So this is just an example of one of our customers. This might be the service that you looked for in our platform, and this might be the service that you own up here on the left. But this is actually all the downstream services that your service relies on. So it looks pretty crazy, I know, but this is actually what begins to happen as you're migrating monoliths out. And we can look at another example too. So in this case, let's say we own this service right here, but downstream from it are these services and upstream are these services. As you can see, as you add microservices, we get like this effect where we see deeper and deeper systems with more and more complexity, where we can no longer understand the transactional logic going on unless we visualize it in a diagram like this. And even then, it's pretty hard to take in. Like, there's no way I'm going to be able to understand the full call stack here of different services getting hit just by looking at this. Now let's get into really how we solve a lot of these complexity challenges with observability. So first, I wanted to talk about de-risking code complexity. Basically, we can leverage application monitoring tools, whether they're open source or whether it's something that you purchased, in order to help de-risk for the additional code complexity as you're doing a migration. I would say first, leverage APM for identifying which code paths and dependencies in the monolith are going to be migrated to the microservice. So we can use things like tracing in order to actually see what those current code paths look like and what the dependencies look like. And then we can understand in the monolith how we're going to carve out our microservice after visualizing where these code paths are. Next, you can verify when those code paths are able to be deprecated and no longer serving traffic. And you can do this with a lot more confidence if you have monitoring along these code paths, because then you can actually see in your APM tool, okay, this particular piece of code or this library is no longer serving traffic, so we're actually safe to deprecate it. Otherwise, you kind of end up with these zombies that are just never deprecated in your monolith that might not even be used anymore. It just adds additional complexity to your engineering teams. Lastly, verifying during deployments of the new service and the old monolith that functionality isn't regressing unexpectedly. So Lightstep in particular is pretty good at this. Essentially, we have a whole tool devoted to this, but essentially what you're doing here is pointing your APM at current deployments and observing to see that functionality is not regressing for that new service and for that old monolith, and making sure that your end users and your upstream services are all healthy. So Lightstep enables you to see this through our deployments page, which actually shows you in real time the performance of your old deployment as well as the latest one that's going out, and just shows you immediately whether your error rate, latency, or throughput is going up in unexpected ways during your deployment. De-risking for performance regressions. So this is kind of similar to the previous one, code complexity, but really here the focus is on de-risking things like bottlenecks. So you can leverage your APM tool for identifying where in the monolith and in the new microservice are going to be any bottlenecks or potential bottlenecks in the future if you do increase scale. Collecting the golden signals, throughput, error rate, and response times that the new microservice needs to support is another thing. You can leverage monitoring or open source monitoring, APM, tools like that that are meant to do this. So really collecting throughput, error rate, response times, latency, those are the golden signals that we always look for in reliability. And we want to collect those for both the new microservice and for the new external infrastructure and third-party services that we need to support now. Lastly, de-risking for external dependencies. So you can leverage APM for enabling developers to see how the new service code is performing in real time as it's being built. So as soon as a developer creates code, basically we want to enable them using any kind of monitoring to verify that the external service is in fact responding to that new code that they've just created. And we want to be able to immediately collect performance metrics on this external service, such as status codes, response times, and error rate. So this allows you to actually de-risk during development time the behavior of the external service upfront. Lastly, just another word on SLOs. We want to be able to wrap the new service in easily debuggable and understandable SLOs to give everyone a clear picture on the state of the world, both during and after completing the code migration. You probably even want to add SLOs for your existing monolith as well, just to understand the effects that the migration is having on your services. So that is all that I wanted to talk about observability related, but I do encourage you to check out Lightstep. So we actually have built our product trying to solve these challenges that we see in both monoliths and microservices day to day. And part of the reason I did join Lightstep actually is because I found this value proposition so compelling with my background. So I really highly recommend checking it out. We do have an interactive sandbox here that's linked that can actually walk you through how Lightstep works. It's pretty fun to go through. It's actually gamified. I enjoy just showing it to my relatives, even if they have never even done software development before, because I think it's a pretty cool interactive demo. So please do check us out. And now let's get to the Q&A.
Stephanie, wow. Speaking of enjoyment, it was a really great session. Thanks for the whirlwind of great advice. Really terrific. Appreciate your time.
Thank you. Thanks for having me.
Our pleasure. You know, you're not going to be surprised. We've got quite a few questions for you. Are you ready for some questions?
Yes, definitely.
Here we go. In migrating monolith, you talked a lot about the idea of protecting yourself from fault or the company from too much risk if and when something might break. How would you suggest people get visibility into their monolith, both before they do the migration, kind of a pre-migration planning stage, and the actual migration?
Yeah, so that's a great question. I would say monoliths benefit from observability no matter what, whether you're actually ready to do that migration or not. Even you can leverage observability to understand when it's actually time to do a migration from an existing monolith. So there's definitely different approaches there in order to do that. There's a lot of agent-based APM tools, including agent-based tracing, that you can actually use that don't even touch the code of the monolith, but can wrap your monolith as it's running and give you pretty good metrics for basically the performance of that monolith to help you understand what the performance is like and bottlenecks before you even begin to perform that microservice migration.
Oh, that's great. That's great. That no-touch visibility, that's really
Yeah.
great, I think, for people. Before we get into a couple of implementation or technical questions, are you seeing in your time, both at Lightstep and just your whole career, are there proven reliable patterns or reference implementations that companies can do? It just seems like there's a level of brain surgery going on here that if you do the wrong thing, something really important might get cut that can't be fixed.
Yeah, definitely. So I would say there's two guiding principles that you can rely on here. One is the strangler pattern, and I'll explain how that works. And essentially, this is actually what we just did in our exercise. Basically, what you're doing with the strangler pattern is you're looking at your current monolith as well as the piece that you want to break apart from that monolith. And then you're keeping the API contract the same to all upstream services that are calling it, but you're breaking that piece out into its own microservice. And then when you actually make the migration switch, essentially you are calling the new service and it looks exactly the same as calling the old service so that the upstream doesn't actually know the difference. And then using this pattern, you can actually do the migration really at your leisure, moving functionality from the monolith into the new service as needed. So you can even just make that new service a facade calling the old service until you're ready to completely transfer all traffic over. The other guiding principle here is domain-driven design. And this can be really helpful when figuring out your domain models and what they look like and where it makes sense to split them up into microservices and where it's just going to add additional complexity with little gain. So those are the two principles that have a lot of examples on GitHub, also just a lot of different walkthroughs online that I would recommend to basically research ahead of time to help templatize the migration so it doesn't feel so much like brain surgery.
Fantastic. This is fantastic. So, Stephanie, you addressed that issue about Lambda, and that was certainly something people do bring up, this idea of whether I go full bore right into serverless. So thanks for that. But here's a related question. It says, we've been experimenting with microservices really without breaking up or migrating an entire monolith. Is that an acceptable practice, or are we taking a half measure?
I would say that's definitely acceptable. Essentially, if you're experimenting with microservices by just migrating pieces of functionality that might not be business critical, that's really just preparing your team for when you need to do that for more critical functionality. So I think it's perfectly reasonable to do that. I've also seen that done with serverless as well.
Oh, fantastic, fantastic. Let's drill into the topic of observability. That's certainly where a lot of your expertise lies, Stephanie. What are some ways that companies can adopt observability while staying with the monolith, and especially during the migration?
Yeah, so as I mentioned earlier, there are a lot of tools that function for both monoliths and microservices that can help you out here. So for example, Lightstep has an integration with Open Tracing, and Open Tracing has an agent that you can actually run. We also can leverage other agents such as Datadog's agent, but essentially all of these are just open sourced agents that can run on your monolith or your microservice and give you observability for very, very little cost. Like literally just turn on that agent and then it'll start reporting to whatever observability product that you have, and then you'll get that visibility both in monoliths and microservices.
We've talked about observability in many dimensions. Let's talk about it after the actual migration, Stephanie. Here's a question I thought was pretty interesting. During or after the migration, the teams that worked on the monolith could feel like they're kind of in no man's land in terms of who's responsible for what. Can Lightstep help customers deal with that?
Yeah, so that's definitely a great use case for any APM tool, including Lightstep. We do actually have a pretty solid onboarding plan for the individual teams who find themselves in that kind of like deep systems triangle I showed earlier. Basically, what you would do to get started is really just start defining your observability at the boundaries of your service. And then you can actually understand which parts of your services do you actually own and which performance bottlenecks and dependencies do you not own that you are not responsible for? And this really provides a clear picture of what your team's current state of the world is, as well as which things you can actually rely on external teams and systems for that you're not responsible for. And then it also provides SLOs out of the box for services that you are responsible for. So our service diagram can visualize even services that you totally don't own at all, as well as the ones that you're responsible for. And it's a great place to orient yourself when you're getting started.
Oh, fantastic. So, Stephanie, I see time is just about up, but before you go, just a quick question here about how folks can get started or go hands-on with Lightstep. Certainly, it seems that there's applicability not just to the folks that do the hard architecture or hand coding work, but even folks that worry about the SLOs or the SLAs once an application's running at the end of the pipeline. So give us a sense how people can orient themselves with what Lightstep does and how they can maybe even go hands-on.
Yeah, definitely. I would recommend first checking out our sandbox. So lightstep.com/sandbox. So that is basically going to show you how Lightstep works without making you sign up for anything crazy or pay money. Basically, it's just a demo to walk you through what modern observability looks like in Lightstep and what you would be getting from Lightstep. And then if you really do want to go hands-on, there is also a developer tier that you can sign up for. You can also just attend one of our meetups. For example, if you go to our blog, we do announce them there and things like that, where we walk through how open tracing works, for example, and other open source tooling that Lightstep does support, but that's more vendor neutral if you're looking for that sort of hands-on experience.
Fantastic, fantastic. Stephanie Baum, software engineer at Lightstep, a really terrific session and really enlightening way to think about how to go from monolith to microservices. Really kind of risky thinking, I think, for many folks here, and that you've been able to give us kind of some X-ray vision into what my future application architecture should look like without breaking anything has been really valuable. Really appreciate your time.
Thanks so much.
Our pleasure, Stephanie, for sure. And as Stephanie mentioned, several resources here toward the end of our Q&A. We've got many of them here, in fact. Just click on any of the links here, either to the trial area or the sandbox, including some PDFs that you can get right here in the breakout room under Stephanie's video. And lots going on at Lightstep, as you can tell. So we actually ran out of room here in the show. Here's a slide that'll take you directly to some Lightstep resources from the Lightstep website. Download Stephanie's slides, and all these links will be live. Thanks again, everyone.